What's going on, guys? So I've got a bit of a different video today. It's not a vlog, but it's actually a leetcode problem. And the reason for that is so I'm currently a software engineer who is applying to positions. And if you know what that's like, you know it involves a lot of this website, leetcode. And generally, for a leetcode problem, if I don't know how to do it, I watch this guy on YouTube. His name's neetcode, and he's kind of just like the GOAT. He does a really good job of illustrating things before he jumps into the code. He explains the concepts very well, and he does everything in Python. So checks off all my boxes 9.5 times out of 10. He is the go-to guy, but every now and then he has a solution that I think is a little bit, it's kind of just like he optimizes it a little bit too much for the purposes of the problem. For example, if you're clicking on this video, it's probably because you were a little bit confused by his solution to 567, permutation and string. And he does this optimization where he counts the number of letters that match, and that reduces it from big O of 26 times n time to big O of n time. But like technically in big O notation, any constants kind of just cancel out. And so I would say that the big O of 26 times n solution is still linear time, which is still great for the purposes of this problem, like understanding the sliding window. And for if you ever see this in a job interview, like I think that the 26 times n time approach works just fine. And so I'm going to show that for you guys here today. So I'm going to just jump into it. I'm assuming that you probably have already watched his video about it. There is the solution that I'm about to present is actually already out there on YouTube, but I didn't see anything in Python specifically. There was some stuff in Java, but I think it's just helpful for someone to have a streamlined approach in Python if they're trying to leak code like me. So I'm going to do my best to explain it and make it intuitive. And just not overcomplicate it. So first things first, just looking at the problem description. So essentially we're looking for if S2 contains a permutation of S1. But the thing about that is like, because we know that S1 and S2 down here tells us that there's only lowercase English letters, if you're looking for different permutations of letters, that essentially is the same thing as an anagram, right? So if you're not familiar, a permutation is a term that comes from mathematics and statistics, and it's when there's a group of elements and each different way of arranging them is a different permutation. So usually it's done with numbers. So like, for example, 1, 2, 3 is a different permutation than 3, 1, 2 or 3, 2, 1 or 2, 1, 3. And with letters, that's essentially an anagram, right? We can look at this problem, which if you have not done, you should definitely do. It's kind of the foundation of solving this problem. So an anagram is a different rearrangement of letters, right? So anagram and then like this nagaram, since they have the same letters but are just rearranged differently, they're permutations of each other or anagrams of each other. And so essentially what we're going to want to do is we're going to want to check every single contiguous substring within S2, right? And check if that is an anagram of S1 or a permutation is the word they used here. And so as you can see here, it has to be contiguous because right here, this doesn't work, but then BA, that is a permutation of AB. You can just put it backwards. But then if there's an O in between the two letters, right, BOA, that's not a permutation of AB. And there's actually no permutation anymore because BOA is just, no matter how you slice it, there's going to be that extra O. You can't turn that into AB, right? And so something that I think is helpful is to just, before you start going into the code, start thinking about how you're going to approach this, right? And so if you have done valid anagram, which again you should, you know that there's this method called using 2 pointers and specifically a sliding window. Essentially, we're going to do the same thing here. So we're going to have 2 pointers. We're going to set them up like this. And at each point, right? So currently our 2 pointers are here, or you could say our window, our sliding window is here. It's CC is at a permutation of AB, right? Every single time we're going to check, is our current window an anagram of AB? Well, the CC is clearly not an anagram of AB, right? And so traditionally what the sliding window does is it's called sliding because if something doesn't work or if you want to keep checking something, then you'll expand the window like that. It'll like move over and then we'll check this new window, right? But hold on here, CCB and AB. It could be CAB, it could be AAB, but the problem is that there's too many letters, right? And so that's something to notice is as soon as we have a size difference or a length difference between the window and the string one, then we automatically know that, hey, that's not a valid permutation, right? BOA, hey, we automatically know that's not a permutation of AB. As such, we can just kind of skip over checking because we know that it's already not going to, it's already going to evaluate to false for being a permutation. So we can just move the window up. And so that's the sliding technique, right? We slid it from CC to CB. And now this is the same length, right? But the letters are different. It's AB versus CB. Obviously, you know that's not an anagram. So we're going to slide the window over. We're going to see that the window is size 3, which is greater than 2. So it doesn't line up. So we're going to slide the window over this way. And now we're at BA, and this is that case that we talked about here, right? BA is an anagram or a permutation of AB. So we're just going to say, hey, return true. We're good to go. But for a counterexample, let's put a C here, right? This is kind of what's going on with this O. We're putting another letter that's not part of it in the middle here, right? So we're going to have our sliding window, and it's going to go through. Again, CC doesn't work. This is too long. Move this up, right? It kind of got this figured out by now. I'm sure you're following. This CB, not a permutation. So we're going to slide this up. CBC, too long, right? We're going to move this up. BC, still not a permutation, right? We're going to move this up. BCA, not a permutation, also too long, right? So we're going to move this up. CA, not a permutation, slide the window over. 3 is bigger than 2, so we're going to slide this left side up. And AC is still not a permutation of AB. And then guess what? We've reached the end of the array, right? And so we know that there are no permutations left, and we can just kind of return false. So intuitively, you might have even been able to come up with that solution on your own, but then it comes to a matter of like, how are we going to put this into code, right? So the first problem is how are we going to just check each time? Like, how are we going to quickly check that each window is equal, is an anagram of the string we're looking for, right? So let's put the pointers back here. For each time, how are we going to know? Well, there is something that we can do, like maybe 80 or 90% of legal problems, we can use a hash map to help quickly identify things. So what we can do is we can have, let's call it S1 letter count, right? And so this is going to be a hash map, or as Python implements it, a dictionary. And what this is going to be is every single letter in the alphabet. So let's say A, B, excuse me, C, and then let's just go all the way down to Z. And it's going to be initialized to 0, right? And it's going to be something really similar for S2. Let's call it S2. Let's call it window, because it's the sliding window. It's not S2 itself, right? It's the window that slides through S2. And what's going to happen is it's going to be able to count. We're going to go through it, and we're going to count how many letters match up. So there's one A in S1, and there's one B, and there's 0 of everything else, which is important. There's a difference between not even having the other letters and then saying that the other letters are 0, right? We want to say that there's 0 so that we can match it up exactly with our window. And we're going to do the same thing in our window, right? So this is that 26, big O of 26 operation that we're saying, right? Because we're going through every single letter, and we're going through this, and because there's 26 letters in the alphabet, that becomes big O of 26 times the length of S1 time, right? And same thing here, we're going to go and we're going to say, hey, there's 2 C's. And then what's going to happen is we're just going to check every single time, is this hash map equal to this hash map, right? Is this the exact same hash map as this one? And again, another big O of 26 operation, because it's going through all 26 keys and values. But that is going to tell us whether or not it's anagram, right? Because if these are the same, then that means that there are the same amount of letters in each one, which means, as you guys know, that that's an anagram, right? It's a very similar approach to valid anagram. And so what we can do is we'll just move our sliding window, and I'm just going to fast forward to the case that we know works, right? And then when that we make it to BA, there's actually 0 C's in there. There's 1A, and there's 1B, and that matches up perfectly, right? That's going to return true. And if it makes it to the end and it never returns true, then we're going to return false. And so, yeah, that's essentially all there is to it, but there's a little bit of setup that goes into it that's a little bit annoying. So first things first, we have to check an edge case. I like to comment my code as I work just so I know what I'm doing, but also I think it's good practice for you guys for if you're ever going to revisit your code or redo a problem, it's good to really comment things out so that you're really understanding the logic. So the first edge case is what we were talking about with our window, right? Our window, we want the length of the window to be the same as S1, but an edge case is what if S1 is actually greater than S2, or rather, what is the length of S1 is actually greater than the length of S2, right? If that's ever the case, then we know that S2 cannot possibly contain any permutations of S1. In fact, it itself as an entire string cannot be a permutation of S1 because it doesn't have enough letters, right? So that's the first thing we're going to check for is if length of S1 is ever greater than the length of S2, then we're going to go ahead and return false, and we know that we're good to go there. And so the next thing that we're going to do is we're going to set up the two, give myself some space here. We're going to set up the two hash maps to keep count of letters, right? And so let's call it, like I said before, S1 letter count and S2 window. And those are going to be two dictionaries. In order to initialize it, like I said, to where we want every single letter and every single count of 0, there might be a better way to do this, but this is the only way I can think of in Python, and it's not even that bad, but it's a little bit tedious. We can say 4-letter in, and then we're going to make a string of all of the lowercase letters in the alphabet. It would be X, Y, Z, because we know that those are all our possible scenarios here, right? All 26. And so for each letter in there, what we're going to do, so we want letter count, right, at that letter, and we're just going to set it up to be 0 because we just want a 0 in for every vowel. We're essentially just initializing it. Equals 0. We're just going to set it. So now, after this runs, we're just going to have two hash maps where all the keys are just every single lowercase letter in the alphabet, and every value is 0 for now. Something that we said was that we always want to make sure that the length of the window is equal to the length of S1. Otherwise, it's not even going to be a permutation, right? And so why not set up the initial sliding window to be the same length as S1. Jeez. Sorry, I don't usually make this many typos. So why not make it initially the same length as S1 and just kind of hit the ground running? The best way to do that is, so we already have checked for this scenario where the length of S2 is at least equal to S1. And so what we can do is we can say for I in range, the length of S1, we can first, we're going to go in and while we're here, right, let's take the letter count of the current letter that we're at within S1. So we're just going to essentially go through and add 1. So what we're going to do is we're just going to count every single letter in S1, and then we're going to add it to our letter count hash map, which is essentially just setting up this portion, right? So now we have an accurate count, and we're going to use this map now. Once everything is counted out perfectly, we're going to use this to compare every single time and have that set up. But we're going to kill two birds with one stone here. We're also going to set up our window, but it's not of S1, it's of S2. And that's because we're not going through S1. We're sliding the window through S2. And so right now what we're doing is we're making the window of S2, and we're going to add 1 to each separate one. So we're going through all of the length of S1 elements through S2, getting that good to go, and then we're setting up our S1 letter count. And so now we have an actual two-pointer. So let's say use two-pointer approach with a sliding window. And so now we can have our pointers, let's call it. So we know that we have went up to how Python works. It goes from 0 up to this, but it doesn't include it. So it goes up to length of S1 minus 1. So we want the left to start with 0, obviously, but then we want the right to be of length of S1, right? Because if this has gone from 0 up to length of S1 minus 1, then we want to make sure that our window goes up to the whole thing. And so now we're just going to we're going to say while right is less than the length of S2, right? So while pretty much making sure that we're just going to go through the rest of S2 and make sure that we're in bounds. While that happens, the first thing that we're going to do, right, the very first thing is we want to check at every single point, hey, if S2 window is ever equal to S1 letter count. This is like Python's way of checking if two hash maps, all the keys and values are the same. That's about big O of 26 time because it's a hash map of length 26. If that's ever happens, right, we can just go ahead and return true. So maybe it's the case that our first initial window is an anagram, and so we can just say true. And if not, right, if not, then what are we going to do? We're going to first expand our sliding window, right? We're going to open it up to add a letter to it. So what we're going to do is we're going to say, hey, S2 window of S2 right? We can add 1 to that, right? And so what we're doing is, let's comment this. So base case, we found a permutation. And then otherwise, so right now, expanding window by taking in a new element to the right. And so now we've added this new element, and then we're gonna actually also, because we know that we want to keep the length of our window the exact same as the length of S1, right? If we're adding something in from the right, it's automatically going to be bigger, right? Because it started out as the length of S1, and then we added 1 to it, so now it's going to be too big. But what we can do is you can just go ahead and remove the left side, right? So we're going to minus equal 1 that, because we're essentially sliding that left pointer up. We're kind of skipping the verification process of, yeah, technically we're not verifying if this new window with this extra right pointer, if that is a permutation, but we already know that it's not going to be a permutation, right? Because we know that's going to be too long. And so what we can do is we can just go ahead and take out that left, and then so not only do we have to do that, we also have to move our pointers up. So move pointers to slide window, and then we'll go right plus equals 1, but also left plus equals 1, right? And so this might be a little counterintuitive at first because we're moving the window all at once, and you might be thinking, hey, aren't we supposed to check between every time we move the window? And yeah, that's true, but we're kind of skipping some processing time because we know that the first time we open up the window and we add 1, it's not going to be a permutation. So we might as well just move the left side of the window back up as well to make sure that it at least satisfies that invariant that we were talking about where the length of the window has to be the same as the length of S1. And then it's just going to run through the loop again, and it's going to check this new window, and then we're going to keep chugging along, right? And then so it's going to return true if it ever finds a permutation. If it ever makes it outside of this loop, we can just return false, right? Well, hold on, not so fast, because what if we've actually made it to length of S2, right? So we've made it to the very end of our S2, but there's a chance that maybe the last 2 characters in the string are the ones that will make a permutation. So for example, looking at this here, so maybe it's like this, right? Maybe it's like this, and it has to be these last 2 that ends up being a permutation of this, right? And by the way, AB can be a permutation of itself. AB is the same as AB. And so we can't just return false. We do have to check one last edge case, right? And so let's say edge case, a permutate, the very last window, or let's say the window at the very end of S2 is a permutation. That's our edge case, right? So we're not going to return false. What we can do right here is we can do something neat. We can just say, hey, is window equal to S1 letter count? Right, essentially what we're doing right here. Because if it is, then we checked for our edge case, and if it's true, then it'll return true. But if it isn't, then we'll just return false, which we were going to do anyways, right? And so we're just going to do one last big O of 26 operation. That's kind of it, actually. I know that it kind of looks like a lot, but I comment out a lot. I'm very verbose in my code writing, and so let's just run it to make sure that I didn't have any typos or anything, but I think I should be good to go. Yep, and I'll submit it to prove to you that it works. So yeah, it's actually really fast, and it is very efficient with memory. And so maybe it's technically a little bit slower than leetcode solution, but I think that this one works great. I hope this was super helpful. Sorry if I went a little bit fast, but I'm kind of assuming that if you're watching this video, you already understand the basics of this problem. It essentially, the crux of it is in this part where you set up the hash maps to count the letters, and then you just go through and you check the letter count each time. But yeah, I hope this is helpful. If you guys want, I can continue making more leak code videos in the future. I'm not the most knowledgeable or smart, but I have been spending a lot of time on it as I'm preparing for software engineering interviews. So if you guys want, I can do more of that. This was pretty fun for me, honestly, and it makes me understand the problem more deeply because I have to in order to explain it. But yeah, I'll see you guys next time.